Hi everyone, welcome back to Calculus with Jackie and Shadow. Today we're going to be talking about some shortcuts for finding derivatives. We're not going to have to use the limit definition every single time. There are some shortcuts, and the first one is the power rule. So let's try to see where this power rule comes from. So Gizmo is flying with the function g of x equals x to the a, where a is an integer. Find a general form of g prime of x in terms of x and a. So if we go over to the calculator, we have g of x equals x to the a. And for the limit definition of the derivative, we have x plus h to the a minus x to the a over h. Now let's think about how we could expand this out and find that derivative. So we're talking about x plus h to the a. We're really talking about x plus h times x plus h on a times. And we can see that here. Now, let's try to find some of the terms of this. If you remember a little bit of binomial theorem, the x to the a term is just going to be 1. It's going to multiply all these x's together. And then the next term is we're going to have a term that's x to the a minus 1 times h. And that's going to be a times because of binomial theorem. And then the next one is going to have an h squared. But if you have an h squared or higher, once you cancel it out with the denominator, that h is just going to go to 0. So now we can do the normal process with the derivatives. We're going to cancel out these x to the a's, and then we have ax to the a minus 1h over h. All the other terms, when we cancel out the h in the numerator and denominator, they're just going to go to 0. The general form of g prime of x is going to be a times x to the a minus 1. So that makes it so much easier to find derivatives. For example, if you have x squared, you can just do the power rule. So the 2, you multiply it by 2, so a equals 2, so you do 2 times x to the 2 minus 1, that's 2x. And then for this one, a equals 3, so it's going to be 3x squared. And finally, for this one, if it's a bigger number like x to the 67, you can still do that. It's just going to be 67 times x to the 67 minus 1, x to the 66. And it even works with negative and rational exponents. It doesn't have to be a positive integer. So x to the 1/2, and you might see square root of x. If you see a radical, just convert it to a fractional power. So the square root of x, or x to the 1/2, if you multiply by the 1/2 and subtract 1 from the 1/2, you get 1/2 x to the negative 1/2. And then for x to the negative 2/3, we got negative 2/3 x to the negative 5/3. And the derivative of a constant is always going to be 0. Now there are certain mathematical operations you can do with derivatives. So let's say that Jackie is fine with j of x equals 2x cubed. You can find the derivative of it. The derivative of x cubed is 3x squared. So just multiply by 2, it's 6x squared. And that works because with derivatives, we really want to think about tangent lines. And if you have a tangent line, you're doing a vertical stretch transformation on the whole graph, including the tangent line. So it's going to make the tangent line twice as steep. And then let's say that Shadow is flying with f of x plus g of x. S prime of x will be f prime of x plus g prime of x. And you can also think about that like tangent lines. Add the lines 3x plus 2, 2x plus 5. You'll get 5x plus 7. And you're just adding the slopes to get the new slope. So that's how that works. And now we can take the derivative of some more complex functions, like 6x cubed plus 7x. Do the power rule, and you get f prime of x equals 18x squared plus 7. And then g of x, we got 5x minus 31x to the fourth. Again, we do the power rule, and we get 5 minus 31 times 4 is 124, and the power goes down by 1, so it's x cubed. And then h of x, 3x to the minus 1 plus 2x to the 6.7. We got a negative and a fractional power, but we can still do the power rule. Remember, we multiply by the negative 1, so we get minus 3x to the negative 2. And then for the 2x to the 6.7, we're going to multiply out by the 6.7. So we get 13.4x to the 5.7. So we subtract 1. So that's it for today, and I'll see you next time.